Math 7, answer key for 8.6, which was graphing translations and reflections. We're doing page 322 to 324, number 1, 2, 3, and 8. All right, question 1 says to identify each transformation and explain your reasoning. So let's look at 1A. Right here, we've got two shapes. They look the same. And you know what? Like if we folded over this y-axis, we'd expect that they would line up actually. They'd line up the same shape. You'll notice this is too long, that's 3 tall, 3 tall. It goes 3 wider and 1 down, 3 wider and 1 down, 3 and 1, up 2 over 1, up 2 over 1, and then up 2 over 2, up 2 over 2. So they are a mirror image, which means that this would be a reflection, right? And what is it a reflection over? What is the thing it's reflecting over? It would be this line right in the middle, right? Notice that this is 5 away, that's 5 away. So it's got to be this center part right here. And what do we call this? Reflection over or in the over the y-axis. That's what we call that line where x is 0 is the y-axis. So there's another couple other words you could say, reflection in the y-axis, or there's a few other things you could say, but there we go. So this is a reflection over a y-axis out of 2 marks. Here we have this shape here, and it looks like it's just moved, and when it moves, that means it's a translation. Now let's figure translation, that's 1 mark, but we need to know how far it moves over and down, right? So from B, we just take one of these points and look at it. Any of these points, it'll be the same amount it moves. B goes 1, 2, 3 to the right. So 3 right. And how many down? 1, 2, 3. 3 down. Okay. 3 right, 3 down. And you could have put units, or if it was centimeters, it was centimeters, but I just want to see that. So you know these shapes look exactly the same, which means it's a translation. These shapes look like they flipped over each other, so it's a reflection. So question 1 is out of 5 marks. All right, question 2 says to describe the horizontal and vertical distance required to move each point in, to its image. So all we're doing is saying how many left or right it goes and how many up or down it goes. So looking at this first one, we have a point here. And you know what? I'm going to draw a little grid just so that we can answer these questions. I like to use a grid to do these questions just so I don't get mixed up. But I'll show you a quicker way once we get to maybe some of our later ones. So A is 5, -3, so go over 5 and then down 3. That's A. And A prime is 2 and 6, so 1, 2, and up to 1, 2, 3, 4, 5, 6. That's A prime. So looking at this, how much did it move horizontally? Well, it moved left, 1, 2, 3. And then it moved up, right? It moved up 9 times. So left, 3, up, 9. And if you think about it, you could also look at your x coordinates, take your first one, subtract your second one, and take this one, subtract and see what the value is, okay? So if you think about it, I'm just going to do the work for A just down here. If we look at our x values for A, if we take 5 and we subtract 2, we'd end up with 3, correct? And subtract means moving left, so we moved left 3, okay? Another way you could look at this would be, you could also go -2 or you could do this, there's probably a better way to do this, is actually to take the place you ended up, right? This 2, and we're going to subtract the first one. 2 and subtract the first one. 2 subtract 5 is -3. That tells you we're moving 3 where negative is left, right? So we had -3 and then we went up, so it's +9. So let's look at the y. Let's take our second value, our 6, second value, and we're going to subtract our first value. Subtract -3, which is the same thing as 6 plus 3, which equals 9. +9, right? So we went up 9. Up is more positive. So that's how you could do it for some of these. Let's do B. -3 and 0. -3 and 0 is B. B prime is -5, -3. So 1, 2, 3, 4, 5, and 3 down. It's right here. So how much did it move? It moved left 2 and down 3. Left 2, down 3. And you could have figured that out by saying where you ended up. Its x value is -5, so -5. Subtract where you started, -3. And that equals -5 plus 3, which is -2. So this value we moved was a -2. And you could look here, take the value you ended up at, which is -3, subtract where it was, which is 0, subtract 0, and that's -3. And look, we went down 3, right? -3. So rather than drawing over and over, I'm going to use these principles I just learned. Take your second one, subtract your first. Okay, so second is 4, subtract 2 is 2. So it's going to be to the right, it's positive, right? So it's right 2. And the y value, 3 subtract -1, which is the same thing as 3 plus 1, is 4 up. It's positive, so it's up 4. D, -1, -4. So -4 subtract 1 is -4 plus 1, right? -4 subtract -1 is the same thing as -4 plus 1, which is -3. So it'll be left 3, and 0 subtract 2 would be subtract 2. Subtract is down, negative is down. So -2, so down 2. E, -3 subtract 3 is 6, so left 6. And 3 subtract 3 is 0. So it's not up or down. Okay. In F, we have 4 subtract 4. So no left or right movement. And then 2 subtract -2 is 2 plus 2. So it's going to be up 4. So for this one, each of these statements, the up will be a mark. So left 3, up 9, that's 2 marks. This is 1, 2, 1, 2, so forth. 1, 2, 1, 2, 1, 2. So 6 questions times 2 is out of 12. Now, if you didn't state the not up nor down, not up nor down, you just said up 4 and left 4, you'd still get the mark for these. It's implied. So it's if you did it or not, as long as you had this left 6 for E and up 4 for F, you are correct. But if you wrote something different than the not up or down, so you said it went up or down any amount, or left or right for question F, it would be wrong. All right, question 3 shows this diagram. There's 4 parallelograms here, A, B, C, and D. I wish they had done it how the coordinates are, going A, B, C, D instead, but they didn't. And it says A, are any 2 parallelograms related by translation? So A is asking about translation. Okay, Let's look at A. Translation, remember, it means it just shifts around. It doesn't turn at all. It just moves left, right, up, down, that kind of thing. So looking here, this shape, it's got 5 long here, right? 1, 2, 3, 4, 5. And this goes down 1, 2, 3, and over 1. Is there another shape that's 5? Well, this has 5 at the top, but it goes the other way. It goes out, so it's not the same. What about this one? Nope, same thing. And it's only 4 on the top, so these would not be translation with each other. But what about this one? It goes 1, 2, 3, 4, 5, and it goes back to the left 1 and down 3. Left 1, down 3. In fact, yes, this would translate all the way over that. So it would move over 10 to the right and then down 7. 10 right, down 7 is what it would translate. But all you have to say is which parallelograms it was that did translate. So A and C is your answer for question A. What about B? B says, are any two parallelograms related by reflection? Well, this is when there be an axis of some sort or a line that they would reflect over and be the same distance from when going perpendicular to the line. So the perpendicular lines to an axis. So what about this y-axis? Looking at the y-axis, we'll notice that this is 1, 2 away to that point, and this is 1, 2 away to that point. And here we have 1, 2, 3, and we have 1, 2, 3. And then to the far ends, we have 1, 2, 3, 4, 5, 6, 7. We have 1, 2, 3, 4, 5, 6, 7. And we also have one more than that we'll see is 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. So if the corner points of it are the same, then those would be reflections. So A and B are reflections of each other. But there's actually also another one. A and B, they go over the y-axis, they reflect over y-axis, but there's also one here that's over the x-axis. We'll notice here that these are 2 away, 2 away, 2 away, 2 away. Here is 5 away and 5 away, and this is 5 away and 5 away as well. So B and C are over the x-axis. Now, why is D not the same? Because we'll notice here and why is it not a translation of B for that first question? Well, if we look here, this is 5, but then there is no point along here that is 5 away, right? This doesn't have a reflected point, and this one here doesn't have a reflected point there. So this shape is not a reflection of this. Same way, this would expect to have this point here reflected here, but it's short of that. So D is not a reflection or translation of any of these. So you get 1 mark, 2 mark, 3 marks for question 3. Just realizing it said to describe the translation. So translation here would be right 10 and down 7. Or maybe you were translating C to A for whatever reason, then it would be left 10 and up 7. You can't mix and match. It would not be correct to say left 10 and then down 7 and then say right 10 and up 7. That would not be correct. But either of these do work as your right answer. So that would actually be an extra mark for the first one for either of those statements. And then also over here, why is it a reflection? This one, A and B, is a reflection over the y-axis. And B and C is over the x-axis. So that each of those statements would also be a mark, and one of these would be another mark. So it's actually out of 6. Sorry, not 3. So for question 8, I'm noticing that I need to move the shape up, down, left, right quite a bit when I read ahead in the question. And I also notice that the numbers that are written are multiples of 2. So I'm actually going to go up by 2. So my scale is going to be up by 2, just because I know I'm moving around quite a bit in this question. So I figured better play it safe and have extra space, okay? So it has a bunch of points that we need to put onto this coordinate grid. A is our first one, which is 2, 4. So over 2, up 4, there's A. B is 4, 4, so over 4, up 4 is B. C is 4, 2, so over 4, up 2, that's C. D is 6, 2, over 6, up 2 is D. And E is 6, 6, so up over 6, up 6 is E. Okay, and it says join points to draw polygon A, B, C, D, E. So do them in order. So it should look like this. A to B, B to C, C to D, D to E, and then E back to A. Part B says to translate 4 units right, 6 units up. Okay, so part B says 4 right, 6 up. Okay, and it says write coordinates for each vertex of the polygon as A prime, B prime, C prime, D prime, and E prime. So this one's going to be our primes. So A was 2, 4. We're moving it right 4. Remember, right makes more positive, so we're adding 4 to whatever our x values are. And it says 6 up. Up is also positive, so we're adding 6 to our y values. So add 4 to each of these and add 6. So A prime becomes add 4 to 2. 2 plus 4 is 6. 4 plus 6 is 10. B prime, 4 plus 4 is 8. 4 plus 6 is 10. C prime, you know what? I'm going to do the adding 4s first for C prime, D prime, and E prime. 4 plus 4 is 8. D prime, 6 plus 4 is 10. And for E prime, 6 plus 4 is 10. Okay, and then to finish with my y's, 2 plus 6 is 8. 2 plus 6 is 8. And 6 plus 6 is 12. Oh, good thing I left some space for this. So let's plot these. A prime is 6, 10, so go over 6 up to 10. That is A prime. Now we know it's translation, so if you want to eyeball guess, that would be 1 over. So this is 1 over would be B prime. And sure enough, 8, 10 is what B prime is. Down here is 8, 8. 8, 8 was C prime. Yeah, we got it right. And over 1, right there would be D prime, which is 10 and 8, 10, 8. And E prime is right here. E prime is 10, 12. So if we go over 10 and up 12, yep. And then we just connect it with a ruler. All right, there we go. We have a shape. It's the same shape. It's just moved. It's translated, which is what we were instructed to do. So if you drew this maybe bigger, if you wrote this on right beside these coordinates, that's okay, but you did need to write the coordinates. It did say that, right? The coordinates of each vertex on the image for the polygon A, B, C, D, okay? If you wrote them to the side, I'm okay with that as well. C, let's just label that as B there. Okay, C says to reflect the image polygon. This is the object. This was what we started with. The image is this one. This is the one we're reflecting here. It says the image polygon, A, B, C, D, E prime. Yeah, it's this one we're going to reflect in the y-axis. So this one's the y-axis, remember? So we're going to use this as our reflection. We're going to reflect it over, okay? And it says to write the coordinates of each vertex of the image polygon A double prime, B double prime, C double prime, D double prime, and E double prime. So remember, you do double primes for the next one, and then triple if there was another one after, so forth. So all you need to do is take this and count how many is it back. It's 1, 2, 3 boxes. So 1, 2, 3 boxes would be A right there, which is A double prime. B would be one more, so that's B double prime. C would be down one from there, is C double prime. Or you could have counted 1, 2, 3, 4, which is actually 8 values, but 4 boxes. D is one more away. Why? Because it's 1, 2, 3, 4, 5 boxes away. So 1, 2, 3, 4, 5 would be D double prime. And E is 1, 2, 3, 4, 5. So we go 1, 2, 3, 4, 5. That's E double prime. And then just connect it. And we need to write the coordinates of this. So I'm just going to keep it organized all on this side. I'm going to do A double prime. If we look, it was -6, +10. -6, +10. And if we compare it, we've moved from quadrant 1, where both are positive, to quadrant 2, where the x value is negative and the y values are all positive. The x values are negative, the y values are positive. So what we can do is notice here, all that changed with our values is it became negative on our x, and that will carry through for all of these. -8 and 10. C prime, double prime I mean, is -8 and 8. D double prime is -10 and 8. And E double prime is -10 and 12. So question D simply asks, now compare this shape to this shape. How are they different? Well, you could describe it a few different ways, but one way, using one word you may have learned in previous years, is congruent. They are congruent, but have different orientations. So they're not rotated or that kind of thing. They're different orientations. They're congruent, but have different orientations. That's one way to describe it. You could also say that it is a reflection and then a translation. There's a few different ways. I'm not giving a mark for D just because there's a lot of things out there that could happen. So putting each of these points on the graph was 5 marks. For B, writing the coordinates, each of those was 5 marks, as well as putting on the graph was 5 marks. For C, writing the correct coordinates was 5 marks, and putting on the graph was 5 marks. So this was out of 15 marks for question 8. Making the whole assignment out of 38. 5 plus 12 is 17, plus 6 is 23, plus 15 is 38.